Hi, and welcome to the segment of Quick Math about simultaneous equations. Here are some quick points on simultaneous equations. First, they have multivariables. Second, if the equation has two variables, we need two equations. Thirdly, the number of required equations will equate the number of variables. Let's jump right on to tutorial walkthrough 1 with emphasis on solving simultaneous equations by equating expressions. Here, solve the simultaneous equations y equals 3x minus 1 and 2x equals y minus 1. Using equating expressions method, you can rearrange the second equation to state y in terms of x, making 2x equals y minus 1 into y equals 2x plus 1. And with both equations being y, we can equate both x expressions, taking 3x minus 1 being equal to 2x plus 1 and solve for x. By inserting this value to the first equation, we can solve for y. Therefore, x is equals to 2 and y being equal to 5 for the given simultaneous equations. In tutorial walkthrough 2, we're going to look at solving the same set of simultaneous equations by substitution. Using the substitution method, the variable y in the second equation can be substituted with 3x plus 1 from the first equation, as shown below, and solve for x. By inserting the x value in the first equation, we can solve for y. In tutorial walkthrough 3, we're going to look at solving the same set of simultaneous equations, this time by elimination. Using the method of elimination, it is good practice to rearrange the equations to have x and y on the left-hand side of the equation. This makes the first equation to be 3x minus y equals 1, and the second equation to be 2x minus y equals minus 1. By performing the operation of subtracting equations 2 from equations 1, for the purpose of eliminating variable y, we can solve for x. By inserting the value of x into equation 1, we can then solve for y. In tutorial walkthrough 4, we're going to look at solving the same set of simultaneous equations by the graph method. By the graph method, you want to express all equations in the form of y equals mx plus c. This turns the second equation to become y equals 2x plus 1. Next, draw the two lines. The required x and y are the coordinates at the point where the two lines intersect. From the diagram, this is the coordinate 2 and 5. Therefore, x is equal 2 and y is equal 5 for the given simultaneous equations. Let me take 20 seconds to explain the relationship. When you solve a simultaneous equation, you're essentially trying to identify the value of x and y that fulfills both equations. In graphical form, the intersect of the two lines is the xy point that is common for the two represented equations. The essence is the same. And before I go on, unless you're asked to solve the simultaneous equations by a certain method, the elimination method works for all instances, and hence this segment will focus on this method. Can one prove that the elimination method makes sense? Okay, let's say A is equal to A, and this cannot be wrong as equation 1, and B being equal to B as equation 2. Notice that it will remain mathematically correct, irrespective of whether you're summing the two equations or subtracting one equation from another. Let's again walk through the steps for solving the simultaneous equations. Which option do we choose in deciding as to whether we add or subtract the two equations? Step 1. Choose the one that will eliminate one of the variables. In the given simultaneous equations, the second and third options will eliminate y. Step 2. Next, try keeping the other variable a positive number. For the given simultaneous equation, the second option will keep x positive. Let's move on to tutorial walkthrough 5. Solve the given simultaneous equations. In this case, you cannot apply any of the options yet until you scale one of the equations. In the example, equation 2 is being scaled by 2 to form equation 3. Now, you can add equation 1 and equation 3 to eliminate the variable y and solve for x. By inserting the value of x into the simpler of the two equations, this being equation 2, you can solve for y. You can always validate correctness by inserting the value of x and y to the other equation, and in this case to equation 1. Tutorial walkthrough 6. Solve this new set of simultaneous equations. For the given simultaneous equations, it makes sense to scale the fraction to reduce complexity. This is done by scaling equation 2 by 3 to form equation 3. Next, we subtract equation 3 from equation 1 to solve for y. By inserting the value of y into the easier equation 1, we can solve for x. You can always validate correctness by inserting the value of x and y to the other equation, in this case to equation 2. In summary, here are the 4 steps of solving simultaneous equations with 2 variables. Step 1. Prepare for elimination. This is done by scaling one of the equations such that one of its variables is the same for both equations. Step 2. Execute the elimination. This is done by executing the addition or subtraction process to eliminate one of the variables. Step 3. Solve for the first variable. Step 4. Solve for the second variable. This is done by inserting the solution from step 3 into the easier of the 2 equations. That's all for this segment. Do visit our other segments of Quick Math if you found this beneficial. Bye bye for now.